So, good afternoon. It's nice to meet you all at this great event. And my name is Jiří Hýbek, and with my colleague Honza Pokorný, we would like to introduce you our universal IoT platform. So at first, we are working at IoT department of TCP, and we are focused mainly on developing our IoT cloud and on integration of devices. In a way, we would like to connect as many different devices possible and try to what we are capable to do with it. We are building a universal platform for Internet of Things. Universal in a mean that we would like to support as many devices and protocols what is possible. And our focus is mainly on creating user-friendly tools. User-friendly means easy to use and easy to integrate. So for integrators to be so simple as possible. I think I can say that our main mission is to create a unique solution from data collection to cloud services. So our platform consists of cloud and a gateway, and today we will be talking more about cloud, and we will show you some real-life examples. About platform, the platform is built on Docker containers and other cloud-native technologies such as Kubernetes for container management and SaltStack for configuration management. And these technologies enables us to deploy the cloud itself on any Docker-enabled environment. So from bare metal to another virtualization methodologies to other cloud providers. The platform is focused on high availability and scalability to provide the best service which is always available and with the highest uptime possible. The really important feature is a multi-tenancy. So we can have many different customers in our platform using it all together, but everyone with a really separated data, separated process. And another feature we are focusing on is a performance and security, and I will tell you more about it later. And as a bonus, we have a built-in private LoRaWAN server, which is a part of our platform of our deployment solution. I would like to tell you more about platform features as itself. I would like to start with a connector component. Connector component is an input point of the platform, and it can collect data using various protocols such as MQTT, HTTP, LoRa, Sigfox, and also IQRF via the gateway. Next part of data pipeline is message processing, and message processing is provided by Tcore application, which is our proprietary software, and Honza will tell you more about it later. Then the process messages are, of course, stored in a database, and then the data are provided to you customers or other integrators using Open Integration API. And this API is just now the direct access to Influx API, so it provides limitless possibilities to integrations and your custom applications. We also offer data visualization, you will see it later, and the great thing is that we support two-way communication. Two-way communication in our case means that you can have one device which publishes message using MQTT protocol, and you can have a second device which can subscribe to this message using HTTP or using LoRa. So we are not only collecting the data, we are also able to interconnect devices all together. Now I would like to pass a word to Honza, and he will tell you more about Tcore.
So thank you for a word. Can we hear? Yeah. Thank you for a word. My name is Honza, and I would like to continue with describing T-Core technology. T-Core is an abbreviation of Temujin Core technology. Is our proprietary software, and it's a part of our IoT gateway, which is the main core of it, and handle low-level and local interfaces such as one-wire, IQRF, and so on technologies. And also, it's included in the IoT cloud as a service where it can handle, for example, LoRa, Sigfox, and a little wide technologies like that. The T-Core, main advantage of T-Core is a protocol translation. Thanks to this technology, we can connect, for example, LoRa and IQRF devices in one network working together. I will show you in the real demo next a little bit later. And we also support the Sigfox technologies, what I said, what Jirka said, MQTT and HTTP protocols, and so on. The other feature of the Temujin Core is not only the protocol processing, but also payload parsing. Because normally sensors receive or publishing data, some raw data, and we don't know what this means. So we need to parse this data into some human readable values. So this is other feature of our Temujin Core. If you can skip this and switch to the Grafana. And we prepared 2 use cases right now, the real use cases, which we want to show you. First is environment demonstration. We can see this one protronic sensor. This is monitor. This is running right now, and we can see the values on the 3 graphs on your right hand. And also, I have just a simple IQRF node with the chip here, and we measure the temperature from this. But this is just the demonstration. Also, if you can open the second row. Okay. So this was demonstration from here, and this is a real use case which running right now in TCP in PSEC. We monitor 10 offices with the COT, carbon dioxide, and also the relative humidity and temperature. And we can also see precipitation in PSEC, relative humidity, outdoor relative humidity, and pressure. Those technologies runs on Sigfox. And the second use case is focused on energetics. Okay, and we can see this DIN rail with the Unipy gateway and some intelligent power socket. And if everything will work, I have just a simple LoRa button here, and when I press this button, okay. Yeah, yes. Right now, power bank is really bad connection. I can see that I remotely turn on this heating, the power socket, and also if the camera can take this, the red LED is turned on. So this is just a simple demonstration how can LoRa communicate with the IQRF and connect those technologies into one network, let's say. Also, we can see on those graphs that the temperature is increasing because I have some one wire temperature here, and that's it. I can turn it off back again. The fan has been turned off, and the LED turned off also as well. So this is the use case, just the demonstration, and again the real usage, which run also in this in TCP. If you can open the last row. And this is the per hour monitoring of electricity consumption in company Progress, which has offices in the TCP building. And we can see 2 graphs. One is based on the IQRF gateway, and the second one is on the LoRa. We can see a little differences between them. It's caused because LoRa they collect data every 10 minutes, while the UniPy takes 10 seconds. So there is a little differences because the derivation of the data is a little bit moved. So this is our use cases, and from my part, it's all. I would, if you have any question, feel free to ask me at our table, and I'm passing the word back to Jirka, and he will continue with the web interface and web management.
Okay, I would like to describe you. This is a web interface of our platform, and today we don't want to just show you slides. So we prepared one surprise or one thing, and it will be live demonstration of one thing, and I hope it won't go wrong. You know it. It always goes wrong. So I hope it will be working today, and. Meanwhile, the Honza prepares it. On this overview, you can see on the left, you can see incoming messages. This is a current rate of incoming messages to our cloud on this testing project. Next to it, you can see outgoing messages, invalid messages, how many metrics we store, and the current use storage in a database. Just for a quick overview, configuration of devices, MQTT credentials, HTTP API, message processing, configuration of T-core parsing, metrics management, visualization as you can see before, and integrations. Here you can see credentials to the API and a quick example how to use it. So, Honza, are we ready?
Yes.
Okay, run it. So we will wait.
Just a minute.
Okay. I will tell you, we prepared a little DDoS attack on our old platform. So we would like to show you how many messages it can handle.
It's running.
Okay. For 7,000 messages per second, 10,000 messages per second. Okay, it's rising. 13, 14. 14, 15. Okay, you can see we can handle 15,000 messages per second. It's in Honza. So 16. And why I'm talking about it? Because performance is important for us. Performance is important for cloud solutions. And this little DDoS attack is a benchmark tool we are using, currently performed against the 5-server cluster. And its MQTT communication and payload was a send message with a numeric value. You saw 50 messages per second, but we write the presentation 9,000 because 9,000 is a safe ratio. We can handle more, but it's safe to handle 9,000. It's approximately 770 million messages per day and 23 billion messages per month. 23 billion messages per month can be 540,000 devices sending one message per minute. And that's a capacity of 5-node cluster of our cloud. So that's all. Thank you for attention. If you have any questions, just meet us at the lobby. Thank you.
Thank you.